example 2, we're going to graph a power function by using a table. So we have this water flowing through this garden hose at a certain rate, gallons per minute, and we want to find the pressure in pounds, pounds per square inch, uh, through testing and measurement. Okay, and so we're given that the pressure P, okay, is given by our flow rate F. Okay, so it's kind of like P is our Y and F is our X, right? So we're given this equation, P of F equals 3 halves times F squared, where F is our flow rate. So if I have a flow rate, I square it, and then I times it by 3 halves, and I get my pressure. Okay, so we want to graph this P of F, and then label its domain and range. Okay, so as we look at this, first we want to find our A and N. So in order to do that, we want to first identify what our A is, meaning our lead coefficient. So, and then our variable is F. So the lead coefficient is in front of the largest exponent, the variable with the largest exponent, which is 2. Largest exponent's 2. So our A would equal 3 halves. Now it wants to identify what is our N, meaning what is our power. So our power is the degree, which is 2, the largest exponent. So now that we have that, we can go ahead and state our domain and range. So I didn't talk about this on the last problem, but I can identify the domain and range based on if it's even, then it'll look like this and this. So it's going to go on forever, negative infinity to infinity. Okay, and then our range would be from the lowest y value up, right? So this one, since we're not adding anything, it's just going to be our range would be from 0 to infinity. Okay, because it's a degree of 2, so it's even, and it's a positive A, so it's going to look like this. So our domain and range would be all real numbers. For our domain, and then our range would be just from 0 to infinity. Okay, so there's our domain and range. Now we can look at creating a table of values. So in order to get a table of values, basically I just want to create a chart, right, of flow rates. So pick some flow rates like -3, -2, -1, 0, 1, 2, and 3. Okay, and what I'm going to do is just plug those into the equation. So 3 halves times that flow rate, our number here, after we square that. Okay, so we're going to square that flow rate first. So 3 times 3 is 9, and then 9 times 3 halves, right, is 13.5. So then this one would also be 13.5, because when I square a negative, it just goes away. This would be 2 squared times 3 halves. Okay, so I take 2 and I square, or -2, and I square it, I get 4. So I get 6. And then so this one would also be 6. And then plug in -1. -1 squared is 1. 3 halves is 1.5. So this one will also be 1.5. And then 0 squared is 0. 0 times anything is 0. Okay, so then we could list these as points, right? This is basically my x, and this is my y, right? So I can list them as points. So -3, 13.5. -2, 6. -1, 1.5. And then 0, 0. And then 1, 1.5. 2, 6, right? They're balanced because it's a squared, so it's a parabola. 13.5. Okay, now that I have that, there's my chart, right? So there I'm doing what I'm asked to do, which was to graph using a table. So now that I have my table, now I can graph these. So I graph these, maybe move that down a little bit, maybe down here since it's going up to 13.5. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So in between there. So -3, 13.5, +3, 13.5, -2, 6, 1, 2, 3, 4, 5, 6, 2, 6, -1, 1.5, positive 1, 1.5, and 0, 0. So now I can go ahead and graph those, and then I can go ahead and connect my parabola. Right, U kind of shaped. A little better than that I could do. Okay, and then I can think about, one thing you can think about is how do you interpret, what does the domain rate mean? What do my x's mean here for this scenario of my flow rate and my pressure? And what do my y's represent? So think about that.